And let's take a look at trig identities. First things we'll look at formulas I wrote down. Our first one is sine theta is equal to 1 over cosecant. Next one is cosine is equal to 1 over secant. Tangent is equal to 1 over cotangent. Cosecant is equal to 1 over sine. Secant is equal to 1 over cosine. Cotangent is equal to 1 over tangent. Tangent is equal to sine over cosine. Cotangent is equal to cosine over sine. Cosine of a negative angle, negative theta, is equal to cosine of positive theta. Secant of negative theta is equal to secant of the positive theta. Sine of the negative theta is equal to negative sine theta. And cosecant of negative theta is equal to negative cosecant theta. Tangent of negative theta is equal to negative tangent theta. Cotangent of negative theta is equal to negative cotangent theta. Sine squared plus cosine squared is equal to 1. Tangent squared plus 1 is equal to secant squared. And 1 plus cotangent squared is equal to cosecant squared. Now these are the ones we're going to be using throughout this section. So let's take a look at our first problem. Okay, so let me come over here and get my tablet. And we got secant theta over cosecant theta. Now the instructions here say rewrite in terms of sine and cosine, and then we're going to simplify it after we've done that. So let me come over here. Secant is 1 over cosine for number 5. So I'm going to use 5 on that one. And cosecant is 1 over sine, which is 4. Okay. So secant is 1 over cosine over 1 over sine. Now if you got a single trig or single fraction downstairs, sorry, flip it and multiply it times your top part. So this becomes 1 over cosine times sine theta over 1. Which gives us sine theta over cosine theta. Sine theta over cosine theta is equal to tangent by number 7. So that's tangent. Let's take a look at second one. We have tangent theta over 1 minus secant times 1 plus secant over 1 plus secant theta. And it says to multiply these, and then we'll simplify. Well, the top part, when I say multiply those, I'm just going to put them next to each other. So we'll have tangent theta next to 1 plus secant theta. Now down below, these are conjugates. Conjugates, the first and the second are the same, the sign in the middle changes. Here's 1 secant, and this one's negative, this one's positive. When you got conjugates, all you have to do is multiply your first parts together, so 1 times 1, and your last parts. Negative secant theta times secant theta is negative secant squared theta. Anytime you have a 1 in one of your trig functions squared, you look at these last three. And we're looking for 1 minus secant squared. Oops. Let's try that again. 1 minus secant squared, which I don't have directly, but I do have number 16. It says tangent squared plus 1. Let me get over there. What number did I say? 16? 16. Which is tangent squared plus 1 equals secant squared. Well, to get it to look like this, I need to take the secant squared over the left side and tangent squared over to the right side. So we'll take this secant squared over here and tangent squared over here. Anytime you take anything across your equals, the sign changes. So this becomes 1 minus secant squared theta is equal to negative tangent squared theta. So this bottom part I can rewrite as negative tangent squared theta. Well, now we got tangent theta times 1 plus secant, and we got tangent squared down here, so one of these tangents can cancel. And we're left with 1 plus secant theta over negative tangent theta. Now I want to simplify this. Simplified means get rid of the fraction if you can. And since we got a single item down here, I can put each item up on top over that. So I'll put 1 over the negative tangent theta plus secant theta over negative tangent theta. Excuse me. Oh. 1 over tangent is cotangent. 1 over tangent is cotangent, number 6. And over here we got secant and tangent, and I can rewrite secant as 1 over cosine, which is number 5. And tangent I can rewrite as sine over cosine. Tangent sine over cosine, number 7. Okay, so this becomes, we said 1 over tangent is cotangent, so that becomes negative cotangent, plus secant is 1 over cosine over negative, and then that's sine over cosine. So it becomes negative cotangent. We can take this negative and put it out in front. If you got a single fraction downstairs, you can flip it and multiply it times your top part. So that becomes times cosine theta over sine theta. So we got negative cotangent theta. Those cosines are going to cancel. There. Ah. Having a little trouble with my tablet. There it goes. Okay. Problem solved, hopefully. So we got minus 1 over sine theta. And 1 over sine is cosecant, which is number 4. So this becomes negative cotangent theta minus cosecant theta. And that's our answer. It's about as simplified as we're going to get on that particular problem. Let's look at number 3 here. We've got 1 over 1 minus sine theta plus 1 over 1 plus sine theta. And it probably says get a common denominator. Rewrite over a common denominator. Well, we have 1 minus sine here, and we have 1 plus sine here. Our common denominator would be these two multiplied together. So we have 1 minus sine theta times 1 plus sine theta. And I'm going to rewrite each fraction with that new denominator. Now this one already had the 1 minus sine theta. The new thing down below is the 1 plus sine theta. So whatever we multiply by the bottom, we have to multiply by the top. So we multiply the top by 1 plus sine theta. Now here, tablet's going to drive me nuts. I dropped a book on it the other day and it bent it, so it keeps unplugging. Well, here I multiplied the bottom part by 1 minus sine, so I need to multiply the top part by 1 minus sine. Okay, so now they have the same denominator, so I can combine together the top parts. Those ones don't do anything there. So we're going to have 1 plus sine theta plus 1 minus sine theta over 1 minus sine theta times 1 plus sine theta. Well, the sine and negative sine cancel each other out. So we're left with 2 up on top. And these are conjugates. I'm going to go ahead and multiply them together. So we'll multiply the first parts. 1 times 1 is 1. minus sine theta times sine theta is sine squared. Now from number 15, I think, 15, sine squared plus cosine squared is equal to 1. So sine squared plus cosine squared is equal to 1. To get it to look like this, all I have to do is take my sine squared over to the right side. So we'd get cosine squared is equal to 1 minus sine squared. So the bottom part here I can rewrite as cosine squared theta. Now cosine, 1 over cosine is secant from number 5. So this becomes, let me show that. We got 2 times 1 over cosine squared. And 1 over cosine is secant, so this becomes 2 secant squared, which I'll put 2 right there. And it's not x, it's theta. Get rid of that. There we go. So our answer is 2 secant squared theta. Okay, let's look at next problem. We got 2 sine squared theta plus 7 sine theta plus 5 over 3 sine squared plus 2 sine minus 1. Now both of these will factor. That's what they tell us to do. They tell us to factor and simplify. Both of these are key number. Top part factors as 2 sine theta. Sine theta, 1 and 5. I guess both of them are plus. The bottom part factors plus minus. So factors that way. Okay, so after we factor the top, factor the bottom, we see the sine theta plus 1s cancel. And we got 2 sine theta plus 5 over 3 sine theta minus 1. And that's our answer. Now if it throws you to factor to this form, go ahead and put p's in for the sign. So we'd have 2p squared plus 7p plus 5. Factor that, and then after you get that done factored, then replace the p with sine. So if it throws you to have it in that form. Let me save this. Trigonometric Identities, page 01, that PDF. Okay, let's look at our next problem, which is actually an identity. So we got cotangent x, sine x is equal to cosine x. Okay, now it says establish each identity. This equals here is not actually an equals. This is more of a question mark. We're wondering if that's true. So you can't treat it like a normal equals. You know, if we were in algebra and you had 3x equals 6, we could divide both sides by 3. You can't do that here. That would be assuming this is equal. If we had 3x minus 2 is equal to 7, we could take the negative 2 to the right side. Again, you cannot do that because that'd be assuming this is equals. What you're going to do is you're going to pick one side, and working with only that one side, you're going to try to rewrite it using your identities to look like the other side. Always you want to start with the harder side. This looks like a harder side, cotangent x, sine x. Well, cotangent is cosine over sine. Cotangent is, where the world is it? There it is. Cotangent is cosine over sine, number 8. So this becomes cosine x over sine x. And that still times the sine x here. Now, one of the tricks that you use is you try to rewrite everything in terms of sine and cosine and see what happens. Sometimes that works, sometimes it doesn't. This time, when I rewrote it, I see that the sines will actually cancel. And that leaves us cosine x, which is the right side. Let's look at this next one. Got cosine squared over sine plus sine is equal to cosecant x. Obviously, the harder side to start with will be the left side. So we're going to work with that. Now I notice on the right side there's no plus here. So what we're going to try to do, doesn't mean it'll work, but we try it, is we're going to rewrite each of these in fraction form, merge them into a single fraction, and see what happens. Because we know we can't have two separate fractions or two separate anythings over here. Well, if you're going to add fractions, it's helpful if they're both fractions. So I'll put the sine x over 1. Now our common denominator we can get by multiplying two denominators together. So it'd be sine x. Now this one already had a sine, so we'll leave it as is. That's cosine squared. Here we multiplied the bottom part by sine, so we have to multiply the top part by sine. So we got sine times sine. So we got cosine squared over sine plus sine times sine is sine squared over sine. Now since they have the same denominator, we're going to merge together the tops and put it into a single fraction. So we've got cosine squared plus sine squared over sine. I think that's from number 15. Cosine squared plus sine squared is equal to 1. There it is. Sine squared plus cosine squared is equal to 1. So 15. So then this becomes 1 over sine x. Now 1 over sine x is cosecant x. 1 over sine is cosecant by number 4. So that becomes cosecant x, which happens to match our other side, which is what we're wanting. Let me grab another drink and then we'll do the next problem. Okay, we got 1 plus 1 minus sine squared times 1 plus tangent squared equals 1. And again, this is a question mark at this point. We're wondering if that's true. We're going to start with the hardest side, which is the left side. Now, anytime that you have the number 1 and a trig function squared, you should think your Pythagorean identities, which are 15, 16, and 17. So 15 says sine squared plus cosine squared is equal to 1. Now this we're going to use for this one. And the other one is 1 plus tangent squared, which is I think 16. 16. Tangent squared plus 1. Okay, now we want the first one here to look like 1 minus sine squared. Well, I can take the sine squared over to the right side. So we would get cosine squared is equal to 1 minus sine squared. Now over here, we want 1 plus tangent squared, which is what we already have here. So we're ready to plug things in. This 1 minus sine squared here becomes cosine squared. 1 plus tangent squared becomes secant squared. Secant is equal to 1 over cosine, Number 5. So this becomes cosine squared times 1 over cosine squared. Which this cancels with that, and we're left with 1, which is what we're wanting. That's what's on the right side. Let's take a look at our next one. And I don't remember this one, how long it is, but let me start a new page just in case. There we go. So we got 3 cosine squared x plus 2 cosine x minus 1 over sine squared. Excuse me, 1 minus 3 cosine over cosine x minus 1. Don't know. You could start with the right side. It looks like this part factors. I don't know if that would actually help us any. Let's try that. So let's start with the left side. Okay, so the top part looks like it factors, so that would be 3 cosine times cosine, 1, 1, and plus here and minus here. Now the bottom part, that's in terms of sine squared, so we want to rewrite that in terms of cosine squared. So that would be 1 minus cosine squared, and we're using 15, I think, 15. When we did that. Okay. Now I can factor a negative out of the bottom part. So we got 3 cosine x minus 1 and cosine x plus 1. And we'll factor a negative out. And that gives us negative 1 plus cosine squared. And then we'll rewrite that. Let me continue over here. So we got 3 cosine x minus 1 times cosine x plus 1. And then I'll rewrite this as cosine squared minus 1. Now that one I can factor. The factor method I used up here was key number. And this is difference of 2 squares. So this becomes 3 cosine x minus 1 times cosine x plus 1. And then cosine x plus 1 and cosine x minus 1. Well, the cosine x plus 1's cancel, so those are going to go away. And we got 3 cosine x minus 1 over negative 1 cosine x minus 1. Now that's real close to the other side. The bottom part's almost perfect, except for the negative down there. The top part, those flipped around. The signs are wrong. Well, we can take this negative 1 here and put it up on top. Like that. And then we're left with cosine x minus 1 down here. Negative 1, and multiply it through. And I get negative 3 cosine x plus 1 over cosine x minus 1. And then we can flip those around and we get 1 minus 3 cosine x over cosine x minus 1, which matches our other side. So that's our answer. Let's look at our next problem. we got 1 minus cosine squared over secant squared minus 1 equals cosine squared. Here we have 1 minus cosine squared and secant squared minus 1. Those kind of remind us of our different properties. Number 15, we have cosine squared x plus sine squared x is equal to 1. At number 16, we have tangent squared x plus 1 is equal to secant squared x. So the top part here I could rewrite as sine squared. Take the cosine squared over here, and we get sine squared is equal to 1 minus cosine squared. The bottom part, if I take the 1 over, then we get tangent squared is equal to secant squared minus 1. Okay, so the top part here becomes sine squared. I'm working with the left side, obviously. The bottom part becomes tangent squared. Well, we're going to rewrite tangent as sine over cosine. Tangent is sine over cosine, number 7. Oh, excuse me. So this becomes sine squared over cosine squared. Now, if you have a single fraction downstairs like we have here, you flip it and multiply it times your top part. So we got sine squared times cosine squared over sine squared. And once we do that, these sine squareds cancel, and we're left with cosine squared, which is what we have on the right side. Let's look at our next problem. And just in case, let me save this. There we go. So this is number 10. Tangent squared over secant x plus 1 equals 1 minus cosine x over cosine x. Now, whenever we see a trig function and a 1, a single trig function and a 1, we think of the reciprocal. So let's start with this left side. Did I say reciprocal? Slap my head. Conjugate. So we're going to multiply the top and bottom by the secant x minus 1. Conjugate is the first and the second part are the same, the sign in the middle is different. So this is secant 1, so this is plus, so this is minus. Well, top part we'll just put next to each other. We'll come back to that. Secant x minus 1. The bottom part, when you got conjugates, all you have to do is multiply your first parts together and your last parts. Secant times secant gives us secant squared. 1 times negative 1 is negative 1. Now from property 16, I'm actually remembering those. We got tangent squared plus 1 is equal to secant squared. I can take the 1 over, and we get tangent squared is equal to secant squared minus 1. So this bottom part here, the secant squared minus 1, we can rewrite as tangent squared. Like that. When we do that, this tangent squared cancels that tangent squared. And we're left with secant x minus 1. Now it doesn't hurt to look or see where you're headed. We need cosine. Well, that's easy. Secant is equal to 1 over cosine. Excuse me. Number 5. So secant becomes 1 over cosine minus 1. Now we got a single fraction on the right side, which means we need to rewrite each of these in fraction form. So put the 1 over 1. Now our common denominator, if I multiply these two together, we get cosine. So cosine's our common denominator. First fraction already has that. The second fraction, it had a 1 as a denominator. I multiplied the bottom part by 1 to get my new denominator, so I have to multiply the top. I multiplied the bottom part by cosine, so I have to multiply the top part by cosine. Well, they have the same denominators now, so I can merge them together. And we got 1 minus cosine over cosine. Okay, let's look at this next one. We got tangent x plus sine x over tangent x minus sine x equals secant x plus 1 over secant x minus 1. This one's got a little bit of a trick to it. You notice that this is a single fraction, this is a single fraction. Here we have something plus something, here we have something plus something. Here we have something minus something, here we have something minus something. What you do is you focus in on one little piece, like see where this 1 is? I look at this sign and I ask myself, what would I divide by this to get a 1 there? And we would divide everything by sine, so that's what we'll do. So tangent x over sine x plus sine x over sine x over tangent x over sine x minus sine x over sine x. Well, tangent I can rewrite as sine over cosine. Tangent sine over cosine is property 7. So this becomes sine x over cosine x all over sine x. Sine x divided by sine x is 1. And then down here I'll rewrite tangent as sine over cosine. And this will be minus 1. Well, we got our top fraction divided by sine, so this would be sine x over cosine x divided by sine. That's what that's saying, plus 1. And same thing down here. So we got sine over cosine divided by sine, minus 1. Well, if I'm going to divide fractions, it's helpful if they're both fractions. So this would be sine x over cosine x divided by sine x over 1 plus 1. And this one will be the same thing. Sine x over cosine x divided by sine x over 1 minus 1. Well, we never actually divide fractions. We rewrite as multiplication. So this will be sine x over cosine x times 1 over sine x plus 1. And same thing down here. We got sine over cosine times 1 over sine minus 1. Do that, these signs cancel here. And we're left with 1 over cosine plus 1 and 1 over cosine minus 1. Now 1 over cosine is secant from 5. So this becomes secant x plus 1 and secant x minus 1. Now let's see how close I am. We're done. So that would be our problem. So let me save that. And let me grab another drink. Okay. Let's look at our next problem. I sort of remember this one from class, but tangent squared minus sine squared is equal to tangent squared sine squared. Now I'm trying to remember what I did in class. I think I started with this side. I'm trying to think if I can see it. Oh, I see it. Okay. So I'm going to start with the right side. The thing about identities is if you don't see it, you just dive right in and see what happens. You don't sit there until you actually see it. Well, this one right here, I'm going to rewrite sine squared, and this is from 15. Let me write that over here. 15 is sine squared plus cosine squared is equal to 1. And if I take cosine squared to the right side, I would get sine squared is equal to 1 minus cosine squared. So this becomes tangent squared times 1 minus cosine squared. And if I multiply that through, tangent squared times 1 is tangent squared. Tangent squared times negative cosine is negative tangent squared cosine squared. Now tangent is sine over cosine, which number 7. So I can rewrite this problem as tangent squared minus sine squared over cosine squared. Now what made me think along these lines is I know I needed a minus in there. And the Pythagorean Identities allows me to put a minus in there. Well, the cosine squareds cancel, excuse me. And we're left with tangent squared minus sine squared, which is, I think, what we're wanting. Yep, that's what we wanted. So that'd be our answer. Or our proof, I guess I should say. Let's look at the next problem. So I got 2 minus cosine squared over sine equals cosecant plus sine. Two different options here. I start with the left side, and I'll split these into two separate fractions, 2 over sine and minus cosine squared over sine, and see what happens. I could rewrite cosine squared as 1 minus sine squared, because everything has to be in terms of sine and cosecant. Or I could start with the right side and go from there. But I think I'm going to go... I think I'll start over here. So I'll rewrite that as 2 over sine minus cosine squared over sine. Now, 1 over sine is cosecant. 1 over sine is cosecant, number 4. So this becomes 2 cosecant x minus, and I'll rewrite the cosine squared. This is from number 15. Remember, sine squared plus cosine squared is equal to 1. And I'll take the sine squared over here, and we get cosine squared is equal to 1 minus sine squared. So this top part here I'll rewrite as 1 minus sine squared over sine. Now we want to split this up into separate fractions, so I'll have minus 1 over sine. And this negative flips the sign of everything that follows it. So that's going to change the sign of this and this. So that becomes negative. Negative becomes a positive sine squared over sine. Well, 1 over sine from number 4 again, we used up above. 1 over sine is cosecant, so we can rewrite that as cosecant. And here, one of the signs cancel and just leaves us sine. And 2 cosecant minus cosecant gives us 1 cosecant, or cosecant x, plus sine x. And what we're trying to do. That's what we're trying to do. So that's our solution. Let me save this. And let's look at our next problem. We've got 1 over secant minus tangent equals secant x plus tangent x. Now this one, my first thought is to rearrange my legs so I could actually walk when I get up. I was sitting too long. Is to multiply the top and bottom by the conjugate. See how this is secant minus tangent? Now what makes me think conjugate on that is if I come over here to my Pythagorean, see how secant and tangent are in the same formula? Sine and cosine are in the same formula. Cotangent and cosecant squared are in the same formula. So if you got 2 trig functions squared and they match up like that, well, try to maybe multiply by the conjugate. Doesn't mean it'll work, but we'll try it. Now the conjugate of that is we multiply top and bottom by the secant x plus tangent x. And that's already looking promising because the top part looks like the right side already. Okay, so that gives us secant x plus tangent x. The neat part about conjugates is you multiply the first parts together and last parts. Secant times secant is secant squared, minus tangent times tangent is tangent squared. From property 16, we had tangent squared plus 1 is equal to secant squared. So we can take tangent squared to the right side, and we get 1 is equal to secant squared minus tangent squared. So actually, this bottom part, secant squared minus tangent squared, becomes 1. So we got secant x plus tangent x over 1, which gives us secant x plus tangent x, which is our right side. Okay, let's look at this next one. We got sine x over 1 plus cosine x plus 1 plus cosine x over sine x equals 2 cosecant x. Well, one thing that I could try is I could get a common denominator, merge it into a single fraction. And I don't know if that'll go anywhere, but let's try it and see. Well, our common denominator would be these two denominators multiplied together. So this would be 1 plus cosine x times sine x. And then we want to rewrite this one with the same denominator, 1 plus cosine sine. Now this one already had a 1 plus cosine. We multiplied the bottom part by sine, so we have to multiply the top part by sine. So we got sine times sine. Over here, this already had a sine, so that's still there. We multiplied the bottom part by 1 plus cosine. So we have to multiply the top part by 1 plus cosine. Well, sine times sine is sine squared. Denominator stays as is. This one over here, we multiply these together. 1 times 1 is 1. 1 times cosine is cosine. Cosine times 1 is cosine. And cosine squared times cosine, or cosine times cosine is cosine squared. I'm not sure if this is looking promising, but let's see. I may have went down the wrong path. Well, let's merge all these together. And I see something's nice. So I got sine squared, and we got a cosine squared. I'll put those together. We know what that's equal to. And we got 1 plus cosine x. Cosine x is 2 cosine x over this. Well, from 15, sine squared plus cosine squared is equal to 1. So this becomes 1. So we got 1 plus 2 cosine. And actually, I think I'm seeing it. Then we got 1 plus cosine down below here, and we got sine. Well, up on top, 1 plus 1 is 2, so we got 2 plus 2 cosine. Now I can factor a 2 out of the top, and that gives us 1 plus cosine, the GCF. And now I see that I got a 1 plus cosine here, 1 plus cosine here, and this is working out nice. And I'm left with 2 over sine, which will be 2 cosecant, but let's see what in the world I'm trying to achieve. 2 cosecant. Okay, then 1 over sine from number 4 is cosecant. What did I say, number 4? Yeah. So then this becomes 2 cosecant x, which is our right side. Long problem. Let me save that. And let's look at our next problem. We got 1 over 1 minus cosine x plus 1 over 1 plus cosine x equals 2 cosecant squared x. Well, I can get a common denominator, merge these two fractions together. That seems a logical place to begin since there isn't a plus over here. Our common denominator would be 1 minus cosine times 1 plus cosine. So 1 minus cosine times 1 plus cosine. Now in our first fraction, we had a 1 minus cosine. The new thing we put downstairs was a 1 plus cosine. So whatever we multiply by the bottom, we have to multiply it by the top. So we'll multiply the 1 by 1 plus cosine. Like that. Now over here, we had a 1 plus cosine. It's still down there. The new thing downstairs is a 1 minus cosine. So we'll multiply the top part by 1 minus cosine. Well, they have the same denominator, so I'm going to merge together the two fractions. So we got 1 minus cosine times 1 plus cosine. On the top part, the cosine and a negative cosine cancel, and 1 plus 1 gives us 2. Well, if I multiply these together, they're conjugates. Multiply the first parts together, 1 times 1 is 1. Negative cosine times cosine gives us negative cosine squared. And from 15, we have sine squared plus cosine squared is equal to 1. If I take the cosine squared over, we get sine squared is equal to 1 minus cosine squared. So I can rewrite this as 2 over sine squared. And 1 over sine is cosecant. 1 over sine is cosecant from number 4. So this becomes 2 cosecant squared x, which I think is what we're trying to prove. Yeah. Well, let's look at our next one. Grab a drink here. Number 17. And we got cotangent x minus secant x over sine x cosine x equals cosecant squared x minus cosecant x secant squared x. Well, I got a minus here on the right side. So over here on the left side, we got two items up on top. Items are separated by pluses and minuses. So we can put each item on top over the denominator. That might be some place to start. Then we'd have a minus in the middle. So we got cotangent x over sine x cosine x minus secant x over sine x cosine x. Let me see. Cotangent is cosine over sine. Cotangent, cosine over sine from number 8. So this would be cosine x over sine x over sine x cosine x minus secant. Actually, I think I'll leave that one alone. Let me write this instead as secant x times 1 over sine x times 1 over cosine x. The reason I split that up like that is because this is 1 over sine, 1 over cosine. Well, I can bring this sine here and put it down in the denominator. So this would become cosine x over sine x, cosine x minus secant x times 1 over sine is cosecant, 1 over cosine is secant. So let me come over here. Number 4 is 1 over sine is cosecant. 1 over cosine. 1 over cosine is secant from number 5. Okay. Now, over here, these cosines would cancel. So we'd have 1 over sine squared minus secant x cosecant squared x. And we just said 1 over sine from number 4 is cosecant, so this one becomes cosecant squared minus secant x cosecant squared x. Let's see, what am I supposed to achieve? Cosecant squared minus... Ooh, that's close. That screw up. Let me go back up there and look. Sure enough, I did screw up. Secant times secant is secant squared. Let's try that again. Okay, so this would be cosecant x secant squared, which then would be cosecant x secant squared. And, well, they flip around, but basically that's the same thing. So that's our answer. So let me save this. I like trig identities. They're just kind of fun. Try to get the other side. A little bit of a challenge, a little bit of a puzzle. And let's look at our last problem. So number 18. We got tangent squared negative x minus cosecant x over cosecant negative x equals 1 over cosine squared. Well, obviously I'll start with the left side. We'll come back to the tangent squared, but over here we've got cosecant x, and cosecant of a negative angle, you can take the negative and put it out in front. like that. And that's from cosecant of negative number 12. So that's from 12. Now when I do that, cosecant divided by cosecant is 1. And negative becomes positive. So this now becomes tangent squared of negative x plus 1. And what this means is this means tangent of negative x times tangent of negative x plus 1. Which means we can take the negative and put it out in front. So we got negative tangent x times negative tangent x plus 1. And negative times a negative is positive, so this just becomes tangent squared. Now it looks like it you just drop it, but the reason why is what I just said here. Negative times a negative is positive. And from number 16, I think it is, we got tangent squared x plus 1 is equal to secant squared. So this here becomes secant squared, which, is that what we're trying to show? Nope, 1 over cosine squared. And secant squared we can rewrite as 1 over cosine squared from property secant number 5. And that's our proof. And actually into that section, so let me save this. Which is good, I gotta go across the street to go to class. I don't know why it does that. So let me stop my recorders. F10.